So throughout this video, we're going to have a look at how to calculate the area of a trapezoid. But before we get into that, I wanted to do a quick review of how we calculate the area of other polygons. So I'm going to start off just by looking at finding the area of a rectangle. This is the first shape that we really learn how to find the area of, and this will allow us to look at the basic theory behind finding area. So the idea of area is that we choose a unit, so I'm going to put some units on here and we'll assume that this is maybe 3 meters by 4 meters. I realize the measurements are totally inaccurate. What we're really doing when we multiply length times width is we're creating an array. And when we multiply the length 4 by the width 3, we're really just counting the boxes in a fast way. We're saying that there are 4 columns with 3 in each column. So here our area would be 12 meters square, or 12 square meters. Again, I realize that the units are totally absurd, but the concept is what really matters. So when we look at a shape like a parallelogram, we're basically doing the same thing, but we want to find a way of calculating the area of this shape where we can still use length times width. But because it's slightly irregular with the different angles, we no longer can create perfect squares. So what we do is we mentally break this apart and create a rectangle. So instead of using the length and the width, because while this works, the angles here make it so that we don't have a rectangle. So instead, we mentally break this apart and we find the height, which in essence takes this triangle, moves it over here, and turns the shape into a rectangle. So instead of using length times width, no, we use length times height. And we create a mental rectangle which still finds the area of this parallelogram. It's relying on the fact that this and this are the same, and we can mentally move one to the other side and create a rectangle. So what strategy are we using when we're looking at a triangle? Well, we're using a similar concept to what we did with the parallelogram. With the triangle, again, we use the base, and then we multiply by the height, and then we divide by 2. Well, what we're really doing, and on this particular triangle we could frame it different ways, what we're really doing is, like the parallelogram, we're taking one side of the triangle, moving it over, and that creates a mental rectangle. Half the base times the height, and we get a rectangle which is the same area as this full triangle. Alternatively, some people like to look at it as creating a full rectangle. So we might look at it this way. We're creating a rectangle that is approximately this shape, and when we divide by 2, we're cutting this part out and we're cutting this part out. So we're left with the area of this triangle. So again, there's a mental representation or a mathematical representation that gets us the area of this shape. Having looked at the concepts behind these 3 shapes, let's explore how we could find the area of a trapezoid. A trapezoid can't be broken up in quite the same way as we could the parallelogram. Certainly, we could chop this part off and move it over here, and that would make us a rectangle, but we don't really have the appropriate length and height to figure that out. What we can do, however, is use a different geometric principle. If I was to take a trapezoid, create two of them, and flip it over, what I get is a parallelogram. And we know how to find the area of a parallelogram. Area of a parallelogram is just base times height. In this case, however, we can't use the base, at least not the base of just the trapezoid. We need the base going all the way from one side to the other. We can use the height. But when we're finished all of this, we're also going to have the area of two trapezoids. So whatever we do here, we're going to have to divide it by 2. Now this is starting to look kind of like the formula for a triangle. So how could we get this base that goes all the way from here to here if we didn't know about this second trapezoid? Well, let's have a look at how to do that. When we flip over the shape, really what we're doing is taking this base, base 1, and we're adding this base, base 2, to the bottom. There's base 2, and there's base 1. We've just flipped it over. So if we wanted this full base to find the area of a parallelogram, we're going to take base 1 plus base 2. We're going to multiply it by the height. And that's going to give us the area of this entire parallelogram. But we only want half of it. So we want to divide the whole thing by 2. This would give us the area of a trapezoid. Let's try it. Would it work on a shape like this? Certainly when we discussed that first potential trapezoid, we said we could take this side and flip it over and move it here, but in this case we can't do that. That's why we use the formula or the method that I've been walking through here, because if I was to copy this, I could move it over, flip it upside down, and in fact in this case our base and our height actually give us a full rectangle. So in this case we would just have base 1 plus base 2, this side plus this side, times the height, divided by 2. Now this is the method for finding the area of a trapezoid. Try drawing yourself a couple of trapezoids. See if you can do the math for it. Let's try one together now. Here's my trapezoid. I'm just going to sketch it. And I'm going to give this some measurements. Let's say that the bottom is 10 centimeters and the top is 7 centimeters. To follow my formula, I'm going to take the bottom, 10, plus the top. I'm going to multiply it by the height, Let's say the height is 4 centimeters. And I'm going to get 10 plus 7 is 17 times 4, which equals 68 centimeters. But that is mentally creating this shape. I need to divide that number by 2. So my answer will be 34 centimeters square. Can you try one? Here's a sample. What would the area of a trapezoid with a base of 12, a top of 6, and a height of 4 be? Bring your answer in tomorrow morning and be prepared to try a few more trapezoid area problems.